Hello, my name is Catarina Reis. Welcome to the course of Design and Testing of Software. I'm here to guide you through the module of Software Design Patterns. When considering design patterns, we have to start by taking a look at Christopher Alexander, an architect that is responsible for more than 200 building projects around the world and has coined the term pattern language and the movement that it encapsulates by describing good practices in his field. In 1977, he launched his book entitled A Pattern Language, Towns, Buildings, Construction, where he first introduced the term, and he states the following. Each pattern describes a problem that occurs over and over again in our environment, and then describes the core solution to that problem in such a way that you can use the solution a million times over without ever doing it in the same way twice. Regarding software development and patterns, in 1987, Ken Beck and Ward Cunningham first introduced 5 patterns written in Smalltalk to design window-based user interfaces. Later, in 1994, the most widely and classical publication on the topic was published. It has since then been referred to as the patterns from the Gang of Four, GOF, due to the 4 authors that compiled these elements of reusable object-oriented code. They are Eric Gamma, Richard Elm, Ralph Johnson, and John Vlissitz. The book provides us with 23 software design patterns that are considered classical and that will be the basis for our session. Consider the déjà vu feeling where you have somehow already seen this problem and you already solved it, and it would be great to reuse the experience instead of rediscovering it all over again. Instead of rediscovering the entire problem and corresponding solution, consider that you will be reusing the solution that you already tried and worked. According to the Gang of Four, GOF, a software design pattern is a simple and elegant solution to a specific problem in object-oriented software design. Patterns capture solutions that have developed and evolved over time, so they aren't the designs people tend to generate initially. They implied redesign and recoding in a struggle for greater reuse and flexibility in software. Design patterns capture these solutions in a succinct and easily applied form. A pattern is described by the following mandatory elements: a name, the problem that the pattern addresses, the proposed solution for the problem, and the consequences, results and trade-offs that help understand and evaluate the costs and benefits of applying a pattern. In order to create a catalog that is easy to delve into, and patterns are described with the same and consistent format, a template, a uniform structure to present the information making the patterns easier to learn, compare, and use is presented. So, we have the pattern name and classification that conveys the essence of the pattern succinctly, and the classification allows you to know where to start your search. The intent, a short statement that answers what does the design pattern do, what is its rationale and intent, what particular design issue or problem does it address, and the also known as that provides other well-known names for the pattern, if any, a motivation, a scenario that illustrates a design problem and how the class and object structures in the pattern solve the problem. This scenario will help you understand the more abstract description of the pattern. Applicability, what are the situations in which the design pattern can be applied? What are the examples of poor designs that the pattern can address? How can you recognize these situations? And then comes the structure, a graphical representation of the classes in the pattern, diagrams that are very similar to UML. Then we have the participants, the classes and/or objects participating in the design pattern, their responsibilities, and how They collaborate with one another. Later, we have the consequences. How does the pattern support its objectives? What are the trade-offs and results of using the pattern? What aspect of system structure does it let you vary independently? Then we have the implementation with pitfalls, hints, techniques that you should be aware when implementing the pattern. Then we have some sample code, and the official version of the GOF makes code available both in C++ and Smalltalk. We have known uses, examples of the pattern found in real systems. And we have related patterns. What design patterns are closely related to a specific one, what are the important differences, and which other patterns should be used when this one is used. This leads us to the structure of the catalog proposed by the GOF. 23 software design patterns classified by 2 criteria. The purpose reflects what the pattern does. Put it in simple. Creational patterns create objects. Structural patterns deal with the composition of classes and objects. Behavioral patterns describe how classes or objects interact and distribute responsibility. The second criteria is about scope and specifies if the pattern is related to a class or to objects. On the other hand, put it in simple, class patterns deal with interclass relationships, classes, subclasses, superclasses, basically inheritance, fixed at compile time, and this happens for most of the patterns. Object patterns deal with changes that occur at runtime, dynamic behavior that includes the majority of patterns. Creational class patterns differ some part of object creation to subclasses, while creational object patterns refer it to another object. Looking at the structural class patterns use inheritance to compose classes, while the structural object patterns describe ways to assemble objects. The behavioral class patterns use inheritance to describe algorithms and flow of control, whereas the behavior object patterns describe how a group of objects cooperate to perform a task that no single object can carry out alone. This is one suggestion to organize and group the patterns. There are many ways to organize design patterns. Having multiple ways of thinking about patterns will deepen your insight into what they do, how they compare, and when to apply them. So this is in table 1.1, we have the design pattern space grouped by the classification proposed by the GOF. And now let's get to know some patterns better.